Welcome back to fsharpConf. I'm very happy to welcome our next speaker, Vincent. And I've actually visited Vincent some time ago in Montreal, and I almost froze to death. So Vincent, what's the weather like in Montreal?
I'm actually doing this talk from home because of freezing rain.
Okay, well,
not awesome.
That proves my point.
Yes.
Cool. What time is it? That's my other question, because we're running across the globe.
It's 5 in the afternoon.
Yeah. So we've crossed the ocean, and now we're in Americas.
Yeah.
Perfect. So if you're ready, let's switch straight to your talk, and I'll put your slides on. And if you can turn off your video so that we can see all your slides. And this is really going to be a fun talk that I've been looking forward to hear because it contains some useful lessons and some provocative statements like you can actually write bad F# code. Is that right?
We might go that far.
Oh,
We'll see.
All right. Well, the stage is yours. Thank you.
Okay. Thank you for the introduction. As Thomas said, my name is Vincent. I'm based in Montreal, work for Genetec. And this talk is called F# from the trenches, but it's partly lessons of building kind of unusual applications in F#, unusual for the functional programming landscape. So off we go. So the path today will be, first I want to introduce who Genetec is, who I am, and why I'm actually giving this talk. The second part will be describing the context of this talk, which again is about certain applications of F#, which are less usual than what we typically see. I'll then go into one of the two main sections, which will be about how F# fares for those applications, what works well, what works less well, and how to possibly mitigate the risks. And then go into the second big sections, which will be about introducing and growing the use of F# within an organization. And finally, I'll wrap up with some takeaways. So what's Genetec? So we're a private software development company. We're headquartered in Montreal, but we also have major development offices in Paris, France, Sherbrooke, and Quebec, also in the province of Quebec, and also an office in Vienna. So we are mostly known for building large-scale software around physical security, so video surveillance, physical access control, that kind of stuff, and then a domain level above it, so workflows, operations, dispatch, that kind of stuff. So big applications, very high throughput usually. So we have had and keep having for the past 20 plus years success through solid both technology insight, technology strategy, and execution. So we were one of the first players to see that IP cameras were the future, for instance. And we've kept going, and it's been a big part of our success still. So we're still driven by technology and not revenue. So we're seeing that as a side effect. So that kind of brings us to, so that kind of ties into where F# came in at Genetec. So our founder and CEO in the early 90s from programming in C and C++ discovered Erlang and fell in love with it. He had to keep doing C++ for a while, but always had his eyes open on possibility to use Erlang. And in the meantime, lots of stuff happened, including creating Genetec. And in the meantime, we became a .NET shop a couple of years, maybe 2005 or something like that. And then F# came along, and once he spotted it, he saw that it was actually a great way to introduce some of the things that he loved about Erlang in our code base. So he built kind of an actor framework on F# using, custom computation expressions. Thread pool back then was not the .NET thread pool was not very efficient for the throughput we were looking at. So we built it over the CCR, the Microsoft Robotics control and concurrency runtime, which was interesting. And around the same time, that's where I come in the story. So I was doing an internship as part of my bachelor's in math and in the computer vision group. And we crossed paths, found a common interest. So I was working with not Erlang, Haskell back then. So he asked me to join and to lead an effort to build a new appliance entirely in F#, an all new code base. So we have many projects at all levels at this point. So we have a couple dozen people working in F# day to day, and we have stuff from cloud infrastructure to embedded systems to machine learning, and some web. It's been getting better in the past few years, as Don hinted this morning. And just for an idea of scale, just the embedded thing that became like what I started building is about 500,000 lines of code. So fairly large code base. So I built that. So who I am. So I built that, wrote most of the code for the first couple of years, and then built up the teams around it and managed the team. So I've been involved in writing, supporting, hiring, all those fun aspects of a technology choice. So this presentation is going to be a very personal and opinionated talk. It's really like me looking back on my experiences. Most of it based off my own mistakes, so no one should take it personally. It's really just me. And it's going to be focused mostly on growth and scaling, both in terms of code and or organization and teams. And a lot of it will be about taking context and constraints into consideration. So keep in mind that I'm always talking, all the statements are within the context of the stuff that we've done and how we've done it. So to start, what type of system are we talking about? Why are they interesting applications of functional programming? And what are some key properties to look at? So we're looking at most of the stuff that we build is like high reliability, long running information systems. It's often like physical security critical, which means that it has to work. It really just has to work all the time. It might be deployed in the field, so some interesting things about upgrades in there. And although it's not math or data science, it's not line of business and just shifting bits from a database to a web front end and back either. It's fairly complex, lots of state, and most of the domain is stuff that is built organically through like ad hoc human requirements. So it's not a domain that can be easily shrunk to 5 business rules. Even if you think a lot about it, like it's kind of a messy domain, which I think changes a lot some of the applicability of some aspects of functional programming in F#. So some big differences from most uses of functional programming. So in terms of social constraints, it's very different building those massive applications where you have like some churn in employee and you have all those realities of big teams. It's very different than like in-house tools. It's very different where your stuff is deployed in the field and controlling stuff that might be like sensitive to like a tool to price options or something. Not to say that those things are not important, but they're very different. It also has very different maintenance constraints. So if you look at some like really nifty little pipeline on that is made to fit on Twitter or some point freestyle composition, is going to be very different from when you have to actually like have a lot of review happening, a lot of new people coming in, changing that code and stuff breaking into production, and you need to troubleshoot it. And another thing is there's lots of contact points to the external world. So we can't pretend that the whole stack is in F#. Like that's nice when you can make that assumption. That you control all the communication and you can assume that all of your F# types are going to serialize magically. It's nice for some applications. In our case, that's not possible. So we need to be, like a lot of our code is interacting with serial devices. So we had a lot of fun with Reflection to build the mappers for that. And so I want to isolate some 4 key properties that I'll be then using to look at F#. I've been looking at F# through that. So the first one is going to be that, and they're properties of most software. It's just like in the aggregate, I think it's a fairly unique set of properties. So robustness is really key. As I mentioned a few times, it may drive critical infrastructure, so it has to work. They're not necessarily easily upgraded. The applications are very large and keep growing, and that's not because we don't know what we're doing. As I said, they're often very ad hoc built models, so it's very hard to shrink the logic down as much as you can in some other domains. So we're talking about code bases easily in the tens, but often in the hundreds, thousand lines of code, and they're still growing. And being commercial products, continuity is absolutely necessary, which changes a lot of stuff. So the teams must be able to grow and attract and develop new members to handle that growth and other facts of life. So those 4 properties are what I'm going to be using as kind of a framework to look at F# in the first big section, which will contain all of the heretical statements that Thomas hinted to. Oh, and also, as all software, constant change and evolution, sorry. So I'll be looking at each of those in turn and list some aspects of what I've seen work, what I've seen being possible pitfalls, and some ways I suggest either stuff that I've tried and worked, or that I've thought of since that I thought I should have done in retrospect. So first, so what works well? So what is it that worked very well for robustness? So as every statically typed functional programming adherent will tell you, an expressive static type system can reduce large classes of programming errors. I would bring attention to the sentence in italics, which is saying, if used properly. So it's a tool which can help with robustness. It does not go without saying. And assuming that it does is a very risky path to take. And that's the risk. The risk is that naive reading of what I call the FP pop culture can easily lead to poor risk management. So if you just read like Haskell papers and then translate that code to F#, you might end up with really nice looking code. You don't necessarily have super nice risk management. What I've seen happen is things like, we don't need tests, because the kind of tongue-in-cheek statement that if it compiles, it works is taken literally, which I think is wishful thinking at best. So the mitigation is fairly obvious. It's just to be pragmatic. So like a lot of the very nice things about F# are great tools. They're very useful to increase robustness, but they don't give it to you. They help you get there. So I would just suggest like leveraging all of like a lot of code review. Yes, using the type system, maybe using some property-based testing, save time, and some more classical scenario tests. And hopefully you need less than you would need if you were using dynamically typed language. But don't assume that because it compiles, it works, because you're kind of painted yourself in a corner there. So on to the second property, which is growth in terms of the code base. So what works really well, and I must say, like the project that I was involved in, also Thomas, we can hear you typing, I think. Okay, cool. So what works really well, and I don't think the project that I was involved in would have been at all possible without F#. I think there's no way at the scope that it was, it wouldn't have been possible. So the defaults such as immutability and the transformation pipeline style of programming really eased, like changing the code became a lot less risky because we could see more, we could see the impact a lot more easily than we would have in for a typical C# code base. And things like exhaustiveness checking, these things, like they work as advertised. They are great tools for growing a code base, no question there. However, what tends to happen that I've seen is that you build a prototype in F#, and it's a magical experience, and it's still my go-to for anything like this. Problem is the prototype looks good, so you keep the prototype, and I'm a fervent believer that prototypes should be put in the trash, and you should just take the lessons learned and then start anew with like the production constraints in mind. And that's a risk. And the kind of stuff that happens is that in prototypes, you don't need like encapsulation or abstraction. You don't need any of that because you just want to like solve the key part of the problem. And that hinders growth significantly. Like you need some boundaries if you're going to keep changing a system. By which I don't mean necessarily using objects. There's lots of other ways to do that. So some mitigation I could encourage is to, and I haven't been successful in doing that, would be to put in procedures to encourage actually throwing the prototypes away. People are really attached to the thing that is so close to working. But I think that can be a trap. I also suggest don't neglect or ridicule software engineering practices. There's a lot to be learned there, and a lot of stuff that is there, yes, looks silly when you put it into tiny programs. But once you look at bigger systems, there's lots to be learned from that. Oh, I have some specifics also. Which are some things as you're moving from a prototype to a more production-ready code base, would be don't use options for error handling. So that exception eating, returning none helper and your pipeline of option.bind looks really nifty, but once it fails in production and you don't have the exception that happened at some level in that processing, you are not going to like that experience. Don't ask how I know. Avoid tuples as a contract. So make sure to use like records are great. They're perfect for that. And name parameters at least at the boundaries at some boundaries in your system, so that people can know what's happening and have less risk of making mistakes. I would suggest introducing module structure to reveal intention and help discoverability. So the F# assemblies are built that way, and I think it's a great pattern to follow. Because 1,000 functions in a flat namespace is almost impossible to use unless you know exactly what you're looking for. Also, if you're expecting reuse by someone using another CLR language, make sure you follow the F# component design guidelines that I think it's the F# Foundation putting it out now. It's really important. And if you want people to like you, put in some objects that will maybe encapsulate some state and encapsulate also like typical usage patterns of your code. So that would be it. Another thing which is really easy to do is static constructors. So when you put let bindings and do statements in modules, so those are really easy singletons to make, but they're just as bad as any other singletons. So particularly if you're pulling in some other DLLs, it fails at very awkward places. It's not fun to troubleshoot. In terms of continuity, so this is the sad slide, the one sad slide of the whole slide deck. So I can't think of anything where F# particularly helps, like maintaining a team that's able to maintain your software. And the risks are true. They're not as bad as some people claim, but they're not absent either. So it is more difficult to hire people that know and have experience. A risk that is kind of trickier and that I didn't expect at first was that part of the people that you do attract, they may be people that are attracted to the clever programming and have read a lot of Haskell and have read a lot of the theorem prover type stuff, which is all very fun and like good. It's not bad, but it's not great for having a team, having someone be able to get into your team and understand what's happening. And the alternative, the other kind of people that you can attract are people that will learn the syntax for a day, and then they will kind of brute force their way through solving problems. So I'd rather have a C# code base that like has clear policies around using null than having an F# code base with options, but then like random option.gets under the hood that you never know when to expect. It's not idiomatic and it's very hard to review afterwards. Possible mitigations would be really to focus on enforcing understandability standards. So F# and functional programming in general does not lead you to, like, it leads you towards better code, but it will not force you to get there. And I think that's key to understand. Like, if you don't teach the right patterns to people, there's many, many ways to do stuff in F#. It's a broad language. The defaults are there, but they're defaults. And I think teams really need to take it's really never ending coaching job too hard. So they need to take care of stuff. And then final property is change. So our software, like all software, also always has to change. And this is the happy slide to go after the sad slide. So it is so fun. Like, it's still my favorite language to work into, like, by far. So I've listed pros there, but you probably all know about that. So really efficient. You can use the type system to great effect. You can get higher level pattern reuse through iterative functions. It's as great, again, as advertised. But the risk is, again, that those only apply to good idiomatic F#. They don't always apply. If you start doing code golf in your code, like, write it, but then erase it. Don't leave it in there. It's not. And I'm guilty of that, of writing some code that I just thought I was clever when I was writing it, and it led to problems, obviously. So mitigation, that kind of ties in with the previous slide. So we need clear structure to help newcomers learn idiomatic and pragmatic F#. As a community, we probably need to build examples of code bases at varying slides to show some of the evolutionary patterns and how code changes from, like, prototype to production, which, like, some of the points I put in earlier are some of the points there, but they're not all. That's something I think we should work on. So to conclude on those, so there are risks. I think it's fair to say that the language, the ecosystem, and the people in the community have plenty of smarts and tools to address. It is a question of developing and documenting valuable patterns, and I think Scott's domain modeling in F# book is a great start to that. We need, I think, examples of projects moving from seed to adulthood, which I haven't had time to do yet. But we also need some risk management, and that ties into the next section. Be careful about attracting people with promises that don't scale. So if someone expects that it will always be like pretty and declarative once you get to a certain size, like, things change shape, and people have to be ready for that. Anyway, so second big section, which is about introducing and growing the use of F# in an organization. So this is not what we did. This is, in hindsight, what I wish I would have done. We were lucky that things worked out for us, but those are kind of the lessons I would give to anyone attempting such a change. So I would say it's important to make very careful project choice. It's absolutely critical to get adequate technical leadership helping the teams that are using the new technology, F# in this case. It's very important to build trust across the organization, and I strongly suggest crossing the organizational boundaries with concepts and not technology or syntax or things like that. So, in terms of project choice, which is not what we did, I would strongly suggest choosing a self-contained and single-layered module. So by layer here, I mean like the domain layer, or like the business logic layer, or the infrastructure layer. Don't split projects across layer. It becomes really hard to not break code navigation, and then people are just annoyed by the F#. They don't like it because every time they press F12 on something, half the time they press F12 on something, they just go to the disassembly or whatever, depending on the domain. I would strongly suggest following the component design guidelines. I would strongly suggest, if you have an assembly that is named x.f#, it probably shouldn't be a separate project. Like, if you have a legit, like, part of your infrastructure that you want to write in F#, then that's fine, but then you'll have a name for it. If you have just a project where you just throw all the stuff that you write in F# in, and then you just call back and forth between it and the rest of the solution. It's not usable in my experience. I've undid all the cases that we did that. So I think like a library is a great starting point. They provide a great understandable boundary, and they're more classically tested and documented. Like we know how to do a library. We think about how people are going to use it, and we write tests for it, and like we do all of those things. So I think it's a good way to avoid some of those risks. In terms of technical leadership, so if we go back to how to get people to do F#, I saw two main ways. So in some cases, we took someone who was smart and talented, and we dropped an F# book on their desk or a blog post or something to capture their attention. Or we grabbed like some people that were maybe not experienced, but they were motivated. And I've seen both of those things work in all the cases where there was strong technical leadership on a daily basis, and I've seen them fail otherwise. So what tends to happen is one of two things. So either the person like really does their best and tries to get the paradigm well, but it takes some time because they're learning a new paradigm and they don't have assistance. So there's a lot of trial and error, and it takes a lot of time. That does not leave a good impression on the F# project. The other approach, which I hinted to before, is that someone just gets stuff done. So they grab the syntax and then they just wrestle the system until it seems to work. And then you end up with like a lot of mutable fields and records, and you end up with really non-idiomatic code, which does not give you all of the promises that F# has and all that it can give you. So that leader's task should be coaching and code review, much more than writing code, which is always tricky to find someone who's willing to do that, but I think it's absolutely critical to find someone that has that experience. In terms of trust, and this is where I'll say a lot of heretical things, avoid zealotry. So as I said, I think F# is really great. It's an awesome language. I love it. Which means that there's no reason to exaggerate, even though I have exaggerated in the past. So these are some things I suggest not saying, because they're not true. So C# does not suck. It's a pretty decent language as far as object-oriented mainstream languages go. Really usable, which is why people do indeed get things done using C#. So don't go telling people that they're inefficient because of like semicolons or curly braces, because they won't take you very seriously and they won't trust you when you come in with some actual good arguments. Some code in C# will be better than some code in F#. And that's a fact. Don't claim the contrary. Type systems do not catch all bugs. So a lot of stuff is like tests are useful. So you do need to, you don't save that time. And immutability does not avoid all concurrency bugs. It helps some, but if your modeling is terrible, you'll end up with inconsistent data anyway. It's not going to save you, it's going to help you a lot. I would also suggest to beware telling people to reuse your code from other languages unless you've been really careful and have tried it from C#. And that's one of the things that for sure I've done. Like you're in a meeting or some situation, and then you're like, oh, I will solve that problem for you. It will take me 5 minutes because F# is so efficient. And then you can just write the glue around it and use it from C#. But it often turns out that if you do that and you're not experienced, you will actually leave them more work to write the glue than it would have taken them to just write the thing in C# in the first place. So that leaves a really bad taste. In practical terms, I would say think about the F# core version, think about project, DLL signing, all of that stuff can easily get in the way of people trying to use your stuff. The last thing would be to argue or discuss concepts and ideas and not syntax. So last time I gave this talk, the analogy I gave is if I told you that C# is more functional than F# because lambdas only require 2 characters to be defined instead of 6. That's a terrible argument. So in the same way, like curly braces don't slow down people in C#. Like it's just not an issue. I also like really dense code, but it's not going to convince people. And I've had very few problems pitching that language defaults matter. That immutability helps once people get the point and you show them in C#. That having explicit options instead of just nulls by convention, like people get it. And that no shared state concurrency is easier. Like those things are fairly orthogonal from the language and are very good lessons learned. And then people can be interested in using a language where it helps you do those things that are helpful instead of going for the language. So that would be my suggestion. So, takeaways from whole talk. So my 3 main takeaways would be to have fun, be pragmatic, and go for understandability first. So what I mean by having fun is I think hobbyists having fun and getting involved in small projects and being able to kickstart stuff and show value from code really fast in like small 5-hour workshops is critical and is awesome and is a big part of the success of F#. So I think that is critical. Like people shouldn't be writing the prototypes as I was suggesting production code is written. Again, it's all about context. However, I would also suggest people stay open and try things out. So the same that we're all suggesting that people try F# out, I suggest also trying out Pony or Elixir or Erlang, and then keep learning about that because there's a lot to be learned. There's a lot to be learned about using a dynamically typed language. Well, like there's some stuff that you might realize that some stuff is actually easier. Some stuff is harder, but some stuff is easier. And it will be, I think that's an important thing that I've seen myself not do enough. But be pragmatic. So that mostly applies if you're lucky enough to have a day job writing F#. So I would say keep the experimentation in experimental projects or for your weekend. Like in my mind, F# strength is the sweet spot that it hits between like how powerful it is and how practical it is. So I would suggest kind of mirroring that in how you approach both your programming and your design and your communication. That to me, that's the main thing about F# compared to any other language, is where it sits in that graph. Also, like as your program grows, as your system grows, what you have to focus on changes, and that remains true with. So it changes the balance maybe and the timing, and it removes some things that you don't have to focus on, but it doesn't change the nature of software development. So you'll still need to have tests. You'll still need to deal with code size growth, and you'll still need to consider just like operations running your software. Usually, if you're lucky enough to have a day job writing F# and someone is paying you, that means someone wants to use it. So you have to think about operations. And the last one would be to focus on understandability. So again, keep having fun, but don't have too much fun in production code. So, or if you have it, like clean it up after, and really avoid ego-driven and clever code. Like point-free style is so rarely useful. And I like that it's not super idiomatic in F#, but I still see it like in our code base sometimes, and it's not. I've repeated that a few times. Use lots of code reviews to propagate expectations and a style that leverages F#. And that again is the key, is to have that leadership there to propagate those expectations. And lastly, there's many idioms to be learned. So F# will, through defaults and such, it will guide you towards good code. It will do that very well, but it will not bring you there by force, which again is the main strength of F#. But don't believe that it does, or you will possibly paint yourself in a corner where it will be really hard to get out of, and you will put in a lot of effort to compensate. So in conclusion, get proper technical leadership, think hard about context when you're transferring concepts, and F# is so good that there's no need to exaggerate. So that concludes my talk pretty much on time, leaving some time for questions or insults if there are any. So thanks to the organizers for the opportunity. And if anyone wants to take up any of those points after today, you can always, I guess, ping me on Slack, although I'm not always there, or on Twitter, or on by email.
Awesome. Thank you so much for your talk. And thank you so much for sharing all of the hard-learned practical production lessons. And I will switch to the video view. And we actually have a few questions. So the first one, given the prevalence of C# code across the genetic ecosystem, how much integration is there between F# and C# code bases? And is that direct consumption or abstracted using service boundary?
Good question. In practice, because we haven't necessarily, what's worked is service boundaries by far. So again, the first main project that was built was an embedded device. So by definition, it was like a wire protocol between the other components and itself. So that worked well, and a lot of the libraries interactions were not following all the lessons learned that I've put on there. So they became very hard they were so hard to use through C# that people didn't bother and like rewrote the functionality in C# because that was easier than figuring out how to use that F# func with 50 arguments, including F# funcs of F# funcs inside of it.
Thank you. And we have time for one more question. Given the rules of your business, how often do you update dependencies with the purpose to use new features?
Fairly, it depends, is the terrible answer. As I said, like we have systems from stuff that is deployed in the field where we can't necessarily update dependencies as easily because we can't package them with our software, and we have cases for services deployed in the cloud where that's not a problem. So yeah, no clear answer to that. As often as we can. Well, for things like security problems, obviously we have to always. With functionality, sometimes we have to make do without.
Awesome. There are some more questions from F# Slack, but I think we're going to just answer them in Slack. And now I think Thomas will introduce another speaker. So thank you so much for giving your talk. Thank you.
Thank you. Good day.